Well, just like with the arithmetic sequences, we had to find what the nth formula was, the nth term. We had to find how many terms there were in the sequence, and we had to find the sum of the sequence. We're going to now show you how to go about finding the sum of a geometric sequence. You'll notice that if we try to approach this thing like Gauss did, as Corey showed us on Wednesday, adding 3 to 3072, oh, by the way, the one right before this is going to be what? Half of this. We're going to, if we're doubling, then coming back, we would get 1000, what? Let's see, we've got 1, 5, 3, and 6. So it'd be 1536. Okay. But you'll notice if I put 3 with 3000, I get 3072. But when I go to add 6 with 1536, I get 1542, and that is not a constant. This getting a sum of the pairs and then multiplying by how many pairs isn't going to work because the pairs don't add up to the same thing each time. So that approach cannot be utilized with geometric sequences. Here's how we're going to go about doing that. We will say 1 plus 3 plus 6 plus 12 plus 24 plus ... plus 3072. That will represent the sum of this sequence or the series, this geometric series. And since we don't know what the sum is, you'll remember in algebra, whenever you didn't know what something was, what would you do? That's right, you would pick a letter to represent what you didn't understand or what you didn't know. So we don't know what the sum is, so I'm going to say that the sum is S for this. So now what we're going to do is, if we can find out what S is, we'll know what the sum is. So here's how we do that. What we do is we take the ratio, in this case we're doubling each number as we go up, and we multiply both sides of this equation by that ratio. In this case it'll be 2, so S times 2 is 2S. Then we will take 3 and we'll times this whole thing by 2, which will be timesing this by 2, which gives me 6. I'm going to write it right over here. Timesing this by 2 gives me 12. Timesing 12 by 2 gives me 24. And then I'd have a 48, etc. And the 1536 that was right here before that, when I times it by 2, I'm going to get 3072. I got the 1536 when I multiplied half of that times 2 and got that. So I've got this going on. And now I've got to multiply this last one by 2, which is 6144. So what I have done now is I have multiplied the bottom equation, both sides, by 2. And on this side, I kind of staggered it 1 unit to the right. And the reason for that I'll show right now. We learned in solving linear systems, we have a system of two equations here, and I'm going to now subtract the 2. So I'm going to subtract this bottom equation from the top equation. 2s take away s, or 2s take away 1s, is s, or 1s, right? Then 6 take away 6 is 0. 12 take away 12 is 0. 24 take away 24 is 0. All of these give us zeros all the way across here. 0, 0. And now I've got this up on the top, 6,144. and it's the only number remaining in the top. And the only number remaining in the bottom is this, 3. So if I take the top and subtract the bottom, what I end up getting is 6,144 minus 3. Well, that turns out that S is equal to then 6,141. And therefore the sum of this sequence happens to be 6,141. It's that simple. Now, you may ask, what if my ratio here isn't times 2 times 2 times 2? What if it's times 3? If it's times 3, you'll do it the very same way. S is equal to the series you've got. Then you'll take 3 times the S, and then you'll take this times 3, which will be the number up above, because if it's times 3, if that's our ratio, this number will be 3 times that. And all these will cancel out, and I still have this minus this, but we'll have 3s minus s, which will give me 2s. So I'll have a 2s down here, and I'll have to divide by 2 to get that. So there's a little bit of a switch there, and that's the method to get to the sum of a geometric sequence or a geometric series.